Okay, students, in today's video, we are going to learn how to factor each number in a fraction in order to reduce it. We're given 24 over 3. And so we've got to create a tree that shows all the factors of 24 and all the factors of 3. And then we will move forward and I'll show you how to use that factor tree to break down these numbers. So let's take 24. Because this skill is best shown by example. Think of two numbers that can be multiplied together to get 24. The two pairs of numbers that students most often think of are 6 and 4. 6 times 4 is 24, or 3 times 8. 3 times 8 is 24, because that's how you've learned it in your multiplication tables. So there are other ways to get 24. For example, 2 times 12. Okay, and the reason I'm going to use these two factors, these are called factors of 24, because when you multiply them together, you get 24. So that's why they're called factors. So here's 2 times 12, that's 24. I chose the 2 for a very specific reason. It is a prime number. It is, in fact, the smallest prime number that exists. What are prime numbers? Prime numbers are numbers that can only be divided by themselves and 1. So prime numbers have no factors other than that number itself and 1. So here are the first few prime numbers: 2, 3, 5, 7, 11, 13. Each of these numbers is prime because it only has two factors, those factors being that number itself and 1. Okay? So 2 is prime. So 2 times 12 is 24. Well, is 12 prime? No, 12 can be broken down into other factors. What can 12 be broken down into? Well, you could use 2 again, because 2 times 6 is 12. 2 is prime. So with this tree, you put the prime number on the left, and then you put the other number. And you always start with the smallest prime number you can think of. So we started first with 2 times 12. Now we've broken 12 down into 2 times 6. Now we're going to break down 6. Again, we can use 2 times 3. Remember, smallest prime number first on the left, then whatever else. Now 3 is prime, so we're done. If you circle these numbers, you will see that they are all prime numbers. And the interesting thing is, if you multiply them together, you will get your original number. So 2 times 2, that's 4. 4 times 2 is 8. 8 times 3 is 24. So you have factored 24 down to prime numbers. That's great. Okay. Here's the good news. 3 is already prime, so we don't have to factor the denominator. Okay? So now what do we do? Well, we can just, let me move this down a little bit. We can just rewrite our problem. We say 24 over 3 is equal to, now take your straight edge and draw you a longer fraction bar like that. Instead of writing 24 on top here, write these prime factors like this. 2 times, that little dot means times, 2 times 2 times 3. Remember, 2 times 2 times 2 times 3 equals 24. And now just bring the 3 over because 3 is already prime. And so now the process becomes, it's a process of looking in the numerator on top and the denominator on the bottom and asking yourself, are there any numbers, any integers on top and on bottom that are the same? So you look over here, it's kind of like go fish, right? You look up here and you look down here, there's no 2's on the bottom. So the 2's stay. Now you look at the 3. I see a 3, okay? When you see a number on the top and the bottom, you can cancel out that number. You're essentially dividing 3 by 3. And what gets left behind every time you do this is a tiny invisible 1. So it's there, but we often don't write it, right? Out of convenience, because it doesn't change anything. It's kind of pointless. So you have canceled the 3's. Now let's rewrite what's left. What's left is 2 times 2 times 2, right? I mean, of course, there's times 1 over here, but we don't need it. And then on the bottom, there's just that little 1. So now let's bring this back to being a whole number. 2 times 2 is 4. 4 times 2 is 8. So now let's simplify further. 2 times 2 times 2 over 1 equals 8 over 1. That can be simplified further. 8 over 1 is just 8. So this is the more involved process for factoring the numerator and denominator of a fraction in order to reduce that fraction using prime numbers. Let's do another problem where this becomes a little bit more interesting. Let's take 36 on top and 12 on the bottom. First, let's factor 36. We'll do some side work over here. 36. Let's factor 36. What is the smallest prime number that can be a factor of 36? Well, here are some tricks. We know that 2 is the smallest prime number that exists. So look at the 6. It's an even number. If a number ends in an even number, it can always be divided by 2. So we put 2 right here. And you have to ask yourself, what times 2 equals 36? Okay. 2 times 18 equals 36. Okay, now let's factor 18. Remember, the first number has to be the smallest prime number that can be a factor of the number that you're working on. So 2, because 18 is even, 2 is the smallest prime factor of that number. What times 2 equals 18? 2 times 9 equals 18. Okay, now we're going to factor 9. What is the smallest prime number that can be a factor of 9? Well, 9 is an odd number, so it cannot be 2. Let's go up to the next prime number, 3. Is 3 a factor of 9? Yes. What's the other factor? What do you multiply by 3 to get 9? Well, just 3. So now you've factored down to prime numbers in order from the smallest to the largest prime numbers. You've factored 36. do the same thing to 12. Smallest prime number that can be a factor of 12. 12 is an even number. Therefore, the smallest prime number that you can factor is 2. 2 times what equals 12? 2 times 6. Let's break down 6. 6 is an even number, so I put 2 right there. 2 times what equals 6? 2 times 3. 3 is prime, so I'm done. You keep doing this tree thing until you've got nothing but prime numbers around the edges of the tree. Circle those. And now you've got your factors. So what we're going to do now is go back to our original problem and put an equal sign and then draw kind of a large fraction bar. Please use a straight edge to keep your work neat. Now instead of rewriting 36, we're going to write the product of all of 36's prime factors. 2 times 2 times 3 times 3. Okay? 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. We haven't changed this number. We've just broken it down into its constituent prime factors. Now on the bottom, we're going to write 2 times 2 times 3. Let's check it. 2 times 2 is 4. 4 times 3 is 12. Bingo. Now we're going to play our game. Up here, I see a 2, and down here, I see a 2. Cancel, cancel. Again, up here, I see a 2. Down here, I see a 2. Cancel, cancel. Up here, I see a 3. Down here, I see a 3. Cancel, cancel. In this case, the only thing left on the top, let's put an equal sign here and draw a little fraction bar. The only thing I see on the top is a 3. And there's nothing left on the bottom. All of these things have been turned into ones. 1, 1, 1. Up here it's 1, 1, 1. Okay, so on the bottom we can just write 1. Well, 3 over 1 is just 3. So 36/12 can be simplified and reduced to 3. Now, many of you knew that. You said, well, listen, man, 36 over 12 is just 3. You just knew it. But there are problems where it isn't so obvious, and we'll finish this tutorial video by looking at one. Let's break down a number we don't know all the factors of off the top of our heads, and I'm just going to make it up. I'm making it up right now. It's 112 over, let's make up another number, and we'll do 84. 112 84ths. Well, how do we break that down? I know that I can't divide 112 by 84 evenly. There's going to be a remainder. So I've got to do my factoring. So let's take 112 and let's break it down. Now, we don't really know all the factors of 112, but we see that it ends in a 2. 2 is an even number, so we know that the smallest prime factor is a 2. Okay, so what is 112 divided by 2? You've got to do the division. So 112 divided by 2. How many times does 2 go into 1? It doesn't, okay? How many times does 2 go into 11? 2 goes into 11 5 times. 5 times 2 is 10. 11 minus 10 is 1. Bring down the 2. How many times 2 go into 12? 2 goes into 12 6 times. 6 times 2 is 12. 12 minus 12 is 0. There's no remainders. We have a quotient of 56. So back here, we say 2 times 56 is 112. Now let's break down 56. 56 is an even number, so again, the smallest prime number that can be a factor of 56 is 2. So 2 times what equals 56? Another little problem here. Now 56 is inside the division sign, and we have 2 out here. How many times does 2 go into 5? 2 times. 2 times 2 is 4. 5 minus 4 is 1. Bring down the 6. How many times 2 go into 16? 2 goes into 16 8 times. 8 times 2 is 16. 16 minus 16 is 0. There's no remainder. Therefore, back here, 2 times 28, which is our quotient, is 56. Now let's break down 28. Now you're getting down to small enough numbers that you can do it in your head. 8 is even, so we've got 2 as the factor. What times 2 makes 28? 14. Okay, break down 14. Again, 14 is even, smallest is 2. What times 2 makes 14? 7. 7 is a prime number, so you're done. Circle the primes. You should be able to circle all the numbers around the edge of your little tree. All right? So we're going to now do the same thing to 84. I want to make sure you can see this. 84. Let's break down 84 into prime numbers. Think about the smallest prime number that can be a factor of 84. Okay, 84 is an even number, so the smallest prime factor is 2. 2 times what equals 84? Well, if you're not sure, 84 divided by 2 will give you the answer. Okay, how many times does 2 go into 8? 4 times. 4 times 2 is 8. 8 minus 8 is 0. Bring down the 4. How many times does 2 go into 4? 2 times. 2 times 2 is 4. 4 minus 4 is 0. There's no remainder. So the quotient is 42. So 2 times 42 is 84. Now let's break down 42. 42 is also even. So we can put a 2 there. 2 times what equals 42? Well, start doing it in your head now. 21. Let's break down 21. Well, 21's odd. Okay, 21 is an odd number, so we can't use 2. Let's go up to 3. Can 3 be a factor of 21? Absolutely it can. Because 3 times 7 is 21. So now you've broken down 84 into prime numbers. Okay? So now you've got your primes. We're going to go back to our original problem and put an equal sign. Get yourself a straight edge, please, and draw a long fraction bar like that. Now, for 112, we'll replace that up here with the product of all these primes. 2 times 2 times 2 times 2 times 7. That goes on top. Now for 84, we're going to replace it with these prime numbers. 2 times 2 times 3 times 7. 2 times 2 times 3 times 7. And now we can perform our simplification by crossing out the numbers that we have on the top and on the bottom. So I see a 2 on top and on the bottom, cross it out. Here's another pair, 2's. Oh, I've run out, there's no more 2's on the bottom. And there's no 3's on top, so I can't do anything with the 3 there. Those 2 stay, this 3 stays, but my 7's can be canceled. Cancel, cancel. Well, what's left? Let's rewrite so it's clear. Here's what's left. You have 2 times 2 that's left on top, 2 times 2, and on the bottom you have 3. Okay, so let's do the final simplification. 2 times 2 is 4. And then 3 is by itself, so it just comes over. So what that means is the total reduction of this fraction, a 112/84, is 4/3. And that's really amazing because unless you had a machine that could do this for you, there's no way to do this without a lot of pain. I mean, so breaking the numbers down into primes becomes super important. And if you're saying, well, I've got another way of doing it, let me tell you something. If you say, well, I can put this in the calculator, I can always put this in the calculator. Here's the problem. The calculator will not break down the fractions when these numbers are replaced with letters. And that's what's coming up in algebra. We're going to replace the numbers with variables like x and y and z. And when we replace these numbers with variables, your calculator becomes a completely useless tool. And so I want to teach this method, and we will use this method for numbers, and then when we get to the variables, you will know what to do. Okay? So I hope this video has been useful to you, and I strongly encourage you to watch it again until you understand this method of factoring down to primes. Okay, if this video was useful and if you liked it, give it a thumbs up. Please leave a comment in the description or a question. If you haven't already, please subscribe to the channel and hit that notification bell so you are always alerted to new videos. Thank you.